Hi, now we are going to see how to do a curve fitting using the solver tool in Excel. Now let us take the example of water properties, and here if you go back to what we discussed during the heat balance, we were taking the values, certain values from the tables. One of the value is the specific heat of water. So like we took 1 kilocalorie per kg, and the temperature is 130 to 110. Suppose we don't want to refer these tables either for the specific heat of water or for specific heat of air. There is one way to fit a equation from the table. The first thing that we have to do is take the values at different temperatures and then try to fit a curve. And let us see how to do it in Excel. Now these are the temperatures. This is the temperature, and I have taken it from a table and I have entered here. I think the table is available here. This is the table. I have taken the specific heat values. I entered here, and these are the specific heat values. The kilocalorie per kg, and okay, see. Kg degree C. Excuse me. These are the values from the table. Now, what we have to do is to try and fit it in a polynomial equation. The first thing that we did is to put it into a chart, put the table into a chart. That you can do it by going for a insert command. Click here, go here, maybe click the options, and 1 minute. Not this directly. Let's directly click the insert. I think we need more options. This yeah, more line charts. I'll go to XY scatter and scatter with smooth line. XY scatter, scatter with smooth line. You got it. Okay. So this is what I already done. Okay. Like- So now if you see there are two curves here. One up to 30 degree, it's a falling curve, and from 30 it's a rising curve. So we have to develop two equations, and let us see what how to define one of the equation from 30 degree to 100 degree. Okay. So now what I have done is I've assumed a equation here. I've already solved it, but let us start here. And as you can see, from 30 there is one equation from 30 and below, 30 and above, sorry, and another equation 30 and below. For 30 and above, you see that there is a particular value that keeps adding it from, it's a linear curve, but it's not a very smooth linear curve. We can go for a polynomial equation, and here a certain value is being added continuously from 0.998 all the way to 1.007. So we are going up to the power of 3 r cube in this polynomial. The equation we use is a plus b into t being the temperature, plus c into t square plus t cube. Now what do? We give a certain assumed values. Let this be 0.9, and let us give a small value. These are all assumed values. We are going to use the solver to finally arrive at the coefficients. Okay, the coefficients a, b, c, sorry, a, b, c, and d are now assumed, and we are going to use the solver. And how to use the solver? Now these equations are the actual values with these equations are calculated here, and now for this value it's always 0.9, and now the difference between the actual table value and the equation values here. Okay, okay. Now what we have to do is to make this converge to 0 by using solver. Solver is available Here solver, we are going to make this variation to 0 by changing these variables. Okay, we have choose GRG non-value. Let's say, so this is the solution. We don't need this. Maybe just a minute. Turn the paste. And now this is the solver solution. So your equation is A is 0.996. You can use this equation there, here, and similarly you can make another equation for values from 0 to 20 with a similar set of variables. So now for 30 degree to 100 degree, the equation is 0.996 plus, or it is like 0.9966 plus 0.00273 into temperature plus 0.00368 into temperature square. So temperature square plus 0.00400 temperature. I forgot one thing. Since these temperatures are of higher values, when you go to square and cube, I think I have used temperature by 100. I think I have used temperature by 100. Yes, you have to use temperature by 100. This, how do we consider whether it is, yeah, this just T or T by 100 is, we need a bit of experience, and we have to know which is a better way to form the equation. Yeah. So this is the equation. If you, when you know the temperature, you can arrive the specific heat. And similarly, you can do this for temperatures between 0 and 30, and also you can do this for specific heat of air as well. And or maybe if you want, in the next session, we can see how to form the same equation here. And now let us see how it works. Control X. Just let us put it. Control V. What do we do? The temperature. The inlet doesn't work that way. Equal to star is again star, and the temperature is 130. Again, this temperature is, that's it, 1.015 is the specific heat. Okay, you can try this for the specific heat of air as well, using the solver. Try to understand how the curve is, whether it's linear, quadratic, or sometimes polynomial, and then accordingly you can do the curve fitting. Hope this was very useful. Thank you very much.